Okay, here we're going to look at direct collisions between two smooth spheres. Now, one of the laws governing direct collisions between two spheres is the principle of conservation of linear momentum. And this principle states that when two or more bodies collide, the total momentum before impact equals the total momentum after impact, provided there are no external forces. Now, mathematically, we can write this as m1u1 plus m2u2 equals m1v1 plus m2u2, where m1u1 represents the momentum of the first sphere before impact, m2u2 represents the momentum of the second sphere before impact, m1v1 represents the momentum of the first sphere after impact, and m2v2 represents the momentum of the second sphere after impact. A second law governing the collision between two bodies is Newton's experimental law, and this states when two bodies collide, the relative velocity after impact is proportional to the relative velocity before impact in a direction along the line of centres, where the constant of proportionality represents the coefficient of restitution. And mathematically, we can write this as minus E is V1 minus V2 all over U1 minus U2. And note that E must be between 0 and 1. V1 minus V2 represents the relative velocity after impact, and U1 minus U2, this represents the relative velocity before impact. Now here, if we look at an example where we've got a smooth sphere A of mass 2 kilograms and it collides directly with a smooth sphere B of mass 3 kilograms on a smooth horizontal table. If A and B are moving in the same direction with speeds 5 meters per second and 4 meters per second respectively, and we're told the coefficient of restitution between the spheres is 2/3, and we want to find the speed of each sphere after the collision. So we can represent this information on a diagram. We've got our 2 kilogram mass and our 3 kilogram mass. Now U1 represents the initial velocity of the first sphere before impact, and this was given as 5I. U2 represents the initial velocity of the second sphere before impact, and we were told this is 4 times I. Now after impact, we don't know what the two velocities are, so we'll just label these as V1I and V2I. Now firstly, if we apply the principle of conservation of linear momentum, and again this just states m1u1 plus m2u2 equals m1v1 plus m2v2. So if we substitute in for m1, m2, u1 and u2, this implies we're going to get 2 times 5 plus 3 times 4, and this equals 2v1 plus 3v2. So on the left hand side, we're going to get 10 plus 12, which is 22, and this equals 2v1 plus 3v2. So if we label this as equation number 1, as we'll be coming back to this, and secondly then, if we use Newton's experimental law, which this states minus E is V1 minus V2 all over U1 minus U2, and the coefficient of restitution was given as 2/3, so this implies minus 2 over 3 is going to equal V1 minus V2 is our unknowns all over U1, which is 5, minus U2, which is 4. So this implies then minus 2 over 3 is just going to equal V1 minus V2. And if we multiply across by the 3, we get minus 2 equals 3V1 minus 3V2. And I can label this then as equation number 2. So what I've got are two equations with two unknowns, and I can solve these simultaneously. If I just add these together, you can see this minus 3v2 will cancel with this plus 3v2. So equation number 1, I don't need to multiply it by anything, or equation number 2, I won't need to multiply this by anything either. So equation number 1, we had 22 equals 2v1 plus 3v2. And equation number 2, we had minus 2 equals a 3v1 and a minus 3v2. So when adding these together, the v2's cancel. So on the left, we've got 20 equals 5v1. And therefore, v1 works out as 4 meters per second. Now, if we substitute that value into either equation number 1 or equation number 2, if I substitute it into 1, this then becomes 22 equals 2 times 4 plus 3 times v2, which implies 22 equals 8 plus 3v2, which implies bringing the 8 over and subtracting, you get 14 equals 3v2, and therefore v2 is 14 over 3 meters per second. So the two values for the speeds after impact, v1 is 4 meters per second and v2 worked out as 14 over 3 meters per second.